Hello, I'm Spiros Miselis. I will be presenting full rates of exercise throughout the year for IB exams, and I hope it helps your case. Hello again. We continue with Chapter 1, Stoichiometric Relationships. We study the unit reacting masses and volumes. This we call stoichiometric calculation. Let's know the basic knowledge about stoichiometric calculations. The chemical compounds ions and chemical elements involved in a reaction react and are produced in mole ratio according to the stoichiometric coefficients. Let's see an example. Synthesis of ammonia. The reaction is nitrogen and 3 moles hydrogen gives 2 moles ammonia. The reacting ratio by mole is 1 mole nitrogen, 3 mole hydrogen, and 2 moles ammonia. This means that 1 mole of hydrogen reacts completely with 3 moles of hydrogen and then 2 moles of ammonia produced. One. Calculations when we know the amount of reactant that reacts completely. Methodology. Step 1. We write the balanced equation and the mole ratio for reactants and products of interest. Step 2. We calculate the mole of reactant, all or the mole of product. Step 3. We solve the ratio to determine the value of this requested. Let's see some examples. One. Ammonia can be made by the synthesis between nitrogen and hydrogen. Calculate the mass of ammonia when react 85.40 of nitrogen. Let's see the solution. As we said, we write first the reaction. Nitrogen and hydrogen gives ammonia. We put the stoichiometric coefficients to balance the equation, as we see in lesson before. Then we calculate the mole of nitrogen. First, we find MR, (24.02), and then calculate the mole. We used the relationship we divide by MR, by molar mass, sorry, and we have 3.55 mole of hydrogen which are reacted. Then we have the ratio from the balance equation. We have 1 mole nitrogen gives 2 mole ammonia. Now we have to react 3.55 mole nitrogen, and we have the unknown bemol ammonia. So we have the ratio which we'll solve. So we have and we find that produced 7.1 mole ammonia. Then we find the mass, the grammars of ammonia, so we need MR of ammonia. MR is equal AR of nitrogen plus 1 times 1 plus AR of hydrogen times 3. So we have AR of ammonia. Then we find the mass and we have the number of mole times the molar mass of ammonia. And the result is 120.981 grams of ammonia are produced. This is a basic stoichiometric calculation. You must remember to convert the amounts to mole, molecules to mole, mass to mole, volume to mole for gases, and vice versa, mole to molecules, mole to mass, mole to volume for gases. Let's see the second example. Calculate the volume of acetylene at STP produced from the reaction charcoal, water, calcium hydroxide, and acetylene. When reacted 120.04 grams of charcoal. Let's see the solution. First we write the balance equation. And the relation of mole for the chemical compounds we are interested. These are charcoal and acetylene. The relationship is 1 mole for charcoal gives 1 mole of acetylene. We have grammars for charcoal, so we have to convert in mole. First we find MR, and the result is 64.1. So we can convert the grammars of charcoal to mole. So we have the formula. The mass of charcoal, we divide it with molar mass. And the result is 1.87 mole of charcoal. So we can have the stoichiometric calculation. We have the relationship from the equation. 1 mole of charcoal produce 1 mole of acetylene, and we use the experimental mole of charcoal. We find 1.87 and gives bemol of acetylene. So we have to solve the ratio and to find the bemol. And the result is, based on 1.87 mole of acetylene. We want to find the volume at STP of acetylene, so we convert the mole in volume, we use the formula, and we have volume is equal with the number of mole times the molar volume at STP. And the result is 22.4 dimethyl cube. This is the answer from the problem. Let's see the third example. Calculate the total volume at STP of the gases products produced from the complete combustion of 12 grams ethylene by the exactly amount of oxygen. How many mole of oxygen reacted? Let's see the solution. First, we write the equation of the combustion of ethylene. The reactants are ethylene and oxygen. The products are carbon dioxide and water. Then we balanced the equation. First, they have the number of atoms, carbon atoms, so we put 2 as coefficient to carbon dioxide. Then equalize the atom hydrogen, we put 2 for water, and we calculate the numbers of atoms of oxygen in products. We have 6 atoms of oxygen, so we put coefficient 3 in oxygen. Then we have the relationship for the compounds where and elements where interest. These are ethylene, because gives the grammars, carbon dioxide and water because we are interested from products, and oxygen because we want to calculate the mole of oxygen. So we have 1 mole ethylene reacts exactly with 3 mole oxygen and gives 2 mole carbon dioxide and 2 mole water. We know the amount of ethylene in grams, so you have to convert in mole. So we found MR for ethylene. And the result is 28.06. So we have to find the mole of ethylene, and we have 12 grams and divide with molar mass. And the result is 0.43 moles ethylene reacted. Then we have the stoichiometric calculation. We have the relationship from the equation. 1 mole ethylene reacts with 3 mole oxygen and gives 2 mole carbon dioxide and 2 mole water. The experimental data is that we have to 0.43 mole of ethylene, so we have B mole oxygen, C mole carbon dioxide, and D mole water. Then we have to solve the ratio. So we have and the result is 1.29 mole oxygen reacted. Then we have for carbon dioxide and the result is 0.86 mole. And finally, we find the mole of water, which are produced. We found the mole of interest, and then we answer in the exercise, in the problem. First, the volume of products. Products are carbon dioxide. The volume is the number of mole times the molar mass of the molar volume. And the result is 19.522 dm in the cube. Then the volume of water were equal mole, so the result is the same. And the total volume of gases products is $39.044 dm to cube. And the mole of oxygen which are reacted is let's see another example. In the case that we have substances that are not poor, for the calculation we use only the poor substance. Let's see, for example, a sable of 25.20 grams of commercial coal burns completely with oxygen, releasing 40.50 dm to cube of carbon dioxide at STP. Calculate the percent purity of the sub. This is solution. As we said, first we write the balance equation. So we have the equation carbon and oxygen gives carbon dioxide. We are interested about carbon and carbon dioxide. So we have 1 mole gives 1 mole. Then we used the volume of carbon dioxide which produced. So we have the mole are equal with the volume of carbon dioxide divided with molar volume at STP. So we have the number of mole is 1.78 mole. So we can calculate the pure carbon from the stoichiometric calculation. The relationship from balance equation is 1 mole of carbon gives 1 mole of carbon dioxide, and the experimental data is produced 1.78 mole carbon dioxide and b mole of carbon. So we solve the ratio and we have the b mole of pure carbon. So we have that reacts 1.78 mole of pure carbon. Then, for answer the question of the problem is to find the percent purity. We know 25.20 grams of commercial coal contains 1.78 mole of pure carbon. So we have to find the mass of pure carbon. So we have and the mass is 21.38 grams. So, in 25.20 grams of commercial coal, contains 21.38 grams of pure carbon. We need to know in 100 grams of commercial how much grams of pure carbon we have. So we find the 6 grams of pure carbon if we solve the ratio. and the result is 84.84 grams of pure carbon. So the result is 84.84% purity. This is the first video in stoichiometric calculation. We have to see more examples and more problems in the next lesson. Thank you for watching. I hope to help you. Thanks for listening, and more IB chemistry videos to come. If you like the video, and you can support me on Patreon. Thank you.